Hello guys, welcome back to my channel. Today I will be discussing about first four problems of Codeforces Round 894 Div 3. So I was able to quickly solve first four problems, and I think I am doing some minor mistake in problem E because my logic is pretty much clear. So we will talk about first four problems and I will give you idea about E problem. I am missing some edge cases. So yeah, so let's go with the first problem. So the first problem was titled as gift carpets. So uh, just quickly go through the problem statement. So problem statement was pretty much straightforward. We have given a grid having n rows and m columns, and that means the size of the carpet, and we have to move from each column from left to right and see whether we are getting this sequence vik yk. So we will move from left to right, and in each column we will see if we are getting a particular character on or not. So let me just quickly explain it. So let's suppose we have some columns and some rows. So let's suppose here a number of rows is 3 and number of columns are 4. So we have to output whether we can make the string yk. So let's suppose we have some letters written here, a, b, v, I here, and some k here and a here. So in this column we are getting v, in this column we are getting I, in this column we are getting k, and in this column we are getting a. So yeah, so we can output yes. So what we will simply do is, so just see its code. It was a pretty simple one. Yeah, so here I have taken an input of n and m and stored all these characters, and then I have initiated a string s as yk, and then initiated a variable count as 0. Then I moved from every column and just find whether in the particular column we are getting s of count. So let's suppose initially count is 0, then what we will check for, we will check for s of 0. If we get s of 0, then we will increase the counter variable, so it will go to I, means if count 1, then the I second letter, that is I, then it will check for I, and finally after running out of the column, if count is 4, then we will simply output yes, and else simply output no. So that was the first problem, super easy problem. Then we will look for second problem. So it was titled as sequence game. Again, I will say that this was not pretty much hard. So let's see first the problem statement. So again, the problem statement was clear. So let's move here. So what the problem statement was saying that we have initially an array A1, and we are making, sorry, we have initially an array A, this is initial array, and we are making an array B from using the elements of A in such a way that, let's suppose A have elements A1, A2, A3 dot 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 AN, right? So it has n elements. So how we are making, how we are generating B from A? So first we will just simply take the first element to B. Now I will put all those elements in which AI is greater than equal to AI minus 1. So in this array I will take all the elements for which this condition is true, and I will simply put in array B. Now we are given array B and we have to output an array A. So I mean opposite process. We have been given B and we have to output the array A. So what is the logic here? So let me take any test cases. So let's say, I mean just take this one first test case only, 463. So yeah, so we have given array B as 4 6 3, and we have to generate a. So it is sure that the first element will be 4 only. Now what we will be do is we will iterate through the elements of array B, and what we will do, if this element is greater than previous element, then simply we will push back the element in the array A. And if it is smaller than the previous value, then what we will do, we will just push back it two times. Why I have pushed back it two times? So let's suppose this is our initial array A. Then how we will generate B? First I will write 4. Then 6 is again greater than 4. Then simply I will write 6. Now 3 is not greater than or equal to 6. So I will not copy 6 to this one. But this 3 is greater than or equal to its previous element. So I will output this one. So this was the basic logic, or simple one. So just see its code. So again, the code is pretty much simple only. So I have taken input of array, and so don't get confused by A here. Actually, this is B. The given array is actually B, but I have initialized it as A. So that's fine, and I will be storing the answer in vector V. So yeah, first I will be push backing zeroth element to V, and then if n is equal to 1, simply output will be 1. That's obvious. In else case, as I said, I will iterate from 1 to n minus 1, and if it is greater than equal to previous value, then simply I will push back AI, otherwise I will push back AI two times, and then I will output the vector V. So that was the second problem. I will say it was super easy again. Then we will move to problem C. So this was like a tricky one, or maybe I have spent more time than I should have spent. So anyways, let's see this problem. So what this problem is saying, that we have some given array which is decreasing. So that means AI is greater than equal to AI plus 1. And so yeah, so we have to output whether this is symmetrical or not. So we are creating a fence by using all the elements. So as you can see from this example, so we have a given array A as 5 4 3 2 1, right? So here the boulders are shown here, fencing I mean. So 5, this is of length 4, this is of length 3 2, and so on. And now if we will flip this boulders, that means planks are laid horizontally, then what we will be doing, that we will laying it horizontally. So give me a second. Yeah, so this one is 5 4 3 2 1. So what is mean by symmetrical? What I have understood is, uh, let's see this. I mean, if after placing it horizontally also, you will see that its first length is 5, second one length is 4, third one length is 3, and fourth one length is 2, fifth one length is 1. So this is same as this one. So that's why this is symmetrical. So let's understand it with another example. So let's take some test cases here. I mean, yeah, let's take this one. So n is equal to 3 and our array is 4 to 1. Uh, give me a second. Yeah. So our n is 3 and we have uh, array as 4 to 1. So let's just suppose we make a fence like this. Each block denotes one unit. So this is 2, this is again 1. Right. So there may be some simple implementation also for this problem, but what I have done, I will be explaining in this video. So yeah, so that's the thing. Now, if we will just lay it horizontally, so horizontally, so this one horizontal. After placing this one horizontal, this way, then the second one, so it will become this, and third it will become this, right? So from here what we are seeing that we are getting 3, 2, 1 and 1, I mean height, and initially we have 4 to 1. So simply these each elements are not equal to this one, so this cannot be symmetrical. So simply we have to generate this array, right? And we will compare with this array whether it is equal or not. So how to generate this one? So just simply see by this diagram only. Yeah, right. So just see from this side. So your eyes should be this side. So just visualize it. And from this side, what you are saying is, you are saying this one is of length one, this, sorry, height one. I mean, height I am considering this way. So this one is of height 1, this one is of height 2, this one is of height 3. So how we will calculate? So just simply we are seeing that we will just make a difference array and see the difference between adjacent elements of original array A. Let's suppose the difference between first and second element is 2, right? So difference is 2. So we will push back initialize counter variable is equal to 1. So initial height, I mean, is 1. So for d is equal to 2, that means our two boulders will have a height of 1. So I will apply a for loop and push back 2, 2 times 1, right? And then I will increase counter variable again. So counter is 2. Now again, after reaching this, I will see the difference between these two, and it is 1. So I will again push back count d numbers of time. So d number of times means d is here 1. So I will, and count is 2. So I will push back 2 one time. Now again, what is its height? I mean d. D is 1. And counter we have increased previously also. So counter is 3. So how many times we will push back 3? So one time we will push back 3. So this is our array B after laying horizontally. And simply what we will do is either reverse the array B or uh, reverse the array A, and we will compare every element of A and B. If every element is equal, then yeah, sure, we are getting symmetrical. Otherwise it is not symmetrical, right? So let's see its code. So I have taken an input of the array y n plus 1, because to counter the last element of the array, I mean this one, like this one. So I will putting a block of height 0 so that I can calculate difference here in the for loop. So that's why I have created an array of size n plus 1, and I have put the value of nth element of the array as 0. So now if n is 1, so obviously if a0 is 1, then output will be yes, otherwise output will be no. And else cases, I mean if n greater than equal to 2, so what I have said, I have done it here. So count is 1, and then I have initialized a vector v. That means in vector b I am storing the array b after horizontally placing all the blocks. So yeah, and one more thing I have taken care of: if the difference is greater than 2 into 10 to the power 5, because that is the maximum length of the array A, then obviously we have to break it, right? Because it can't be then equal, then the vector v cannot be equal to vector A, because in any step if d is greater than 2 into 10 to the power 5, that means it is greater than the maximum value of n, and that's simply not possible. So that's what I have done here. And yeah, simply here I have compared all the elements if whether they are equal or not. So you can see the code here. I will paste it in the comment section also. So yeah, so now coming to problem D. So problem D was, I will say that it is a good one for at least beginners. So let's see problem 4 first. So the problem statement was, I mean, yeah, this problem statement was not pretty straightforward, but let's see. So simply in a simple sentence, I will say that we have to uh, make exactly n different types of ice cream, right? And the ice cream are said to be different if they are made from different pairs. So for example, here you can see, so 1 2 ice cream made from 1 2 and ice cream made from 2 1 are same because they are made from the same pairs, right? But 1 1 is not same as 1 2. So, and this note section is important that uh, Tema do not need to make all ice cream cones at the same time. This means that he is making ice cream cones independently. In order to make following cone XX for some X, Tina needs at least two types of X. So this line was important. So let's understand this. And N is pretty large here. So let's understand it. So first idea that comes in mind is, let's suppose we have some materials to make ice creams. Uh, Give me a second. Yeah, flavors. So we have some flavors, 1 2 3 dot dot n. So we have some flavors. So to make so how many pairs we can generate from these n? So this is simply nc2. Now if, sorry, let's take it as m because n is already there. So let's n, or x will be better. So xc2 pairs we can create, right? And some pairs and some flavors, I mean, yeah, some what flavors only, yeah, some flavors may be repeated, like let's suppose two is repeated, and let's suppose three is also repeated, right? So there are some flavors which are repeated. So that repeated numbers will create, let's suppose there are y repeated flavors, so that will create y pairs is equal to n. This equation should hold, right? Now in order to solve this, and we will take the maximum value of x possible such that xc2 is less than n, and we will take the maximum possible value of x, right? So that was the logic behind this problem. So what comes in our mind with a large value of n? So simply binary search, right? So we will just apply binary search on answer, and then we'll see. So I will explain it again to make it more clear. So we have, let's suppose we have x flavors, x different types of flavors. So how many pairs we can generate? xc2, right? And there may be some repeated flavors to minimize the total number of flavors used. So as question, yeah, minimum number of balls teamer need to buy, right? So minimum numbers of balls we have to output. So that's why. So there may be some cases in which the balls are repeated, like second balls are is two times, right? So this one is to handle those cases is equal to n. So n is the total number of ice cream pairs, right? So let's see its code. Yeah. So it's simply a binary search. So I have taken input of n. If n is 1, then we will output 2. If n is 2 or 3, then output will be 3. It's obvious only. Now, if n is greater than or equal to 4, so we have applied a binary search here. So lower limit is 2 and higher limit is 10 to the power, I mean, how much? 3, 3, 3, 10. Why I have taken h as 10 to the power 10? Because you can see here, for the maximum value of n 10 to the power 18, I guess, this one is 10 to the power 18. The answer is less than 10 to the power 10, as you can see here. So you can just take it as 10 to the power 10 only. or 10 to the power 11 also will be okay. Why it shouldn't be large like 10 to the power 15 or 16? Because it will exceed the uh, limit of long int here, so that's why. Yeah, so simply we will apply a binary search here, and we have initialized mid as h plus l by 2, and p as mid into mid minus 1 by 2. So this is mid c2. So mc2 can be written as m into m minus 1 by 2. That's why. And if is p is greater than n, then simply h is mid minus 1 and l is mid. So simply that was the binary search. You can see here. I have checked where for the h is less than, for h total number of pairs is less than equal to n. So then I will so this is the y part that I was explaining earlier in this video. So this is the y part. Yeah, this n minus this, right? So that was the fourth problem. For problem E, I will say I have tried it, but uh, I am missing some cases, so I will explain it later in some other videos. Thank you for watching.